Welcome to the unit on Basics of Apparel Production Process. In this unit, you will learn about the role of apparel engineers in the manufacturing process of apparel. The unit will also review definitions and terms associated with apparel engineers. The units on ergonomics and facility layout will highlight methods to optimize human being and overall system performance. This unit comprises of 6 modules and a final review section that invites you to reflect on what you have learned. By the end of this unit, student will able to understand industrial engineering concepts, describe ergonomics, develop appropriate workplace layout, understand the importance of time study, describe line balancing, understand the importance of operation breakdown. The first module will provide an overview of apparel engineering concepts. Engineering is a science by which the property of matter and the sources of energy in nature are made useful to man. This is still quite a mouthful, but there are several keywords in definitions that can help us. One is sciences. This means that there is common knowledge in engineering that there are certain rules that always hold true. The properties of matter and sources of energy covers just about everything we know of. So, let's just refer to this as things. Make useful to man gives us a purpose of engineering. So, now we can say engineering is making things useful to man. Now, let's go one step further and define industrial engineering. Let's define industrial engineering this way. Industrial engineering is the engineering approach applied to all factors, including the human factor involved in production and distribution of products and services. As we will see, a reference to the human factor is very important to industrial engineering in the apparel industry. Industrial engineering differs from other forms of engineering because it involves specifically the functions of production and distribution. Now that we have arrived at a definition of industrial engineering, let's talk about what things are done by an industrial engineer. Let's refer to these as the scope of this job. They are: study, measure and improve the way individuals perform their jobs. Design and install a better system of coordinating the jobs assigned to individuals into a group effort. Specify, predict and evaluate results obtained. From this, we can perhaps oversimplify things for the purpose of understanding. Now, everybody will agree that a simple definition of industrial engineering is a logical way to find out the best way to do something, the time required to do it and the way to measure results. From this, we can now say that apparel engineering is simple industrial engineering applied specifically to apparel industry. Going back to our simple definition, we can say that apparel engineering is finding the best way to do something, the time required to do it and the way to measure results. From here, our discussion will cover apparel engineering. By far, the most common concept of apparel engineering is someone walking around with a stopwatch, timing operators and setting quotas. While it is true that an apparel engineer does time people and set rates, this is only one part of his job. But let's stop here for a few minutes and talk about this phase of apparel engineering. When an engineer times an operator, he is performing the second part of our simple definition, the how long does it take part. Before he does this, however, he should study the job to find out the best way to do it, the first phase of our simple definition. These two steps of finding the best way to do a job and then timing to find out how long it takes are referred to as a motion study and time study. Engineers are taught to do motion study first, as many time study data on incorrect motion is not of much value. Many people assume that the only reason that an engineer does a motion and time study analysis is to set quota and piece rates. But suppose one operator were not going to be paid by a piece rate. Suppose everybody was to be paid a set amount per hour. Why is it useful to do a motion and time study? There are various reasons for time study. Quotas and piece rates. Knowing the quota and piece rates, the sales price can be determined. Costing. By knowing how long it takes to perform a job, the total time and cost of manufacturing a product as well as the sales price can be determined. Manpower planning. By knowing how many units one person can produce, it can be determined how many people are needed to produce a given volume. Machine requirements. The number of machines required can be determined by knowing the output from one machine. Production planning. Time study enables us to measure the production capacity of a plant. Decisions can be made as how much volume to load into a plant. These are only a few of common uses of motion and time study. As we can now see, the informations obtained is useful far beyond just setting quotas and piece rates. As we have already mentioned, motion and time study is the most common function associated with an apparel engineer, but what are some of his other duties? Let's review some of other things we might find an apparel engineer doing. Plant layout deals with identifying the location of machines and equipment to provide the best workflow. Production flow system helps in determining the best way to move work from one job to another, such as individual pieces and tied bundle on trucks. Determining what machines are the best for a given job and what attachments simplify the job. Deciding the best way to pay people for their work efforts. This includes straight time, piece work, split incentive, group incentive, and straight time bonus. Responsibility for operators achieving expected performance level. Operator training. Responsibility for all programs related to training new employee. Production control system. Designing systems for measuring, controlling production flow through the plant. Cutting room. Engineering job in cutting room for incentive plan. This might also include a program to increase material utilization. Quality control. Designing programs to measure and control quality of workmanship in plant. The distribution, overall responsibility of engineer, warehouse and shipping facility. Payroll system, designing payroll procedures to handle many pay system and generate necessary cost reports. And others may have responsible for plant safety, maintenance and supplies. The second module highlights the importance of apparel engineering and benefits of this craft. We can see how that the engineering function in an apparel plant is likely to cover much more than just timing operators and setting piece rates. But the question comes, why is engineering necessary? What good does it accomplish? One of the greatest problems facing any plant manager is that of getting the facts concerning his plant. Without thorough information regarding the plant, the manager almost powerless to take action. One of the basic functions of engineering is to get facts. These facts may be in the form of a time study of the engineer has made or a cost report of the engineer has designed. But in either case, the management is given information to act upon. So we can conclude that one of the basic needs for engineering is the need of management information. The other needs of engineering are for standardization, product scheduling, fair payment to employees, and prevention of any chaos. As supervisors, we can appreciate the need of standard conditions in managing your department. Think of the confusion that would result if each operator on a job performed her work differently from anyone else. Or suppose each operator on a job used a different type machine. What if the payroll department changed its method of paying employees each week? Suppose quality specification changed every day. So what passed yesterday is rejected today. Effective supervision would be impossible without standardization of methods, equipment, and conditions. Engineering helps standardize. In order to run our department efficiently, you need a firm schedule of the production that will be available to you. You know that too much work in your department is just as much as problem as too little work. In either case, your department's ability to produce efficiently is hampered. Suppose there was no way of knowing how much more work your section could handle. Do you think that there would be much of the chance that someone could guess exactly right? As of how much work to load in, of course not. In order to schedule work accurately, someone needs to know how long it takes to go through each operation. Engineering data helps to make this decision. In order to pay employees fairly, we need to know the value of the work they produce. In other words, we need to know if 400 pieces that someone produces on job A is as valuable as 1000 pieces that another person produces on job B. If it is, then person A and person B should receive the same pay. Since part of the engineering function is to measure work, we can compare person A's contribution to person B's contribution and pay them accordingly. It should now be obvious to you that any attempt to run a department without standardized condition, without a production schedule, and without fair payment to the employee is doomed to chaos and failure. Thus, in answering the question of the necessity of engineering, it can be said that without someone performance these functions, it would simply be impossible to operate for long time. Now that we have looked at some of the reasons engineering is needed, let's look at the benefits we receive from it. They are work simplification, increased production, increased profit, and increased earnings. One of the main objectives of almost any engineering effort is that it makes work simple to perform. This holds true for operators, supervisors, and the top management. When an engineer analyzes any area of work, he does so with thought in mind. How can I make this easier to do? When he answers this question, he has simplified the job and made it better. Do not mislead into thinking, however, what work simplification means people will be doing less works. They may in fact do more work but within the same amount of time as before. Because work has been simplified, people's ability to produce is increased. The ability to produce more within the same amount of time is a company insurance for survival. This ability means that the company can now accept more work. It means that cost can be lowered by avoiding having to work overtime. It means that fixed costs can be spread out over more units of production. It means that profits improve. When a company's profits increase, everyone involved is in a better position. Owner, stakeholders prosper. Management supervisions are rewarded for their performance. More money is for the operators. A company is able to expand, which creates more jobs, and finally more jobs improves the economy of the area in which company is located. Most engineering projects not only increase company profits but also result in higher earnings for employees. Most companies are willing and in fact eager to share with its employees the financial gains that are available with engineering. These modules provides an overview of apparel engineering tools and techniques. Industrial engineering, which is often substituted by the term work study, has two fundamental parts. First is method study and second one is work measurement. In this unit, we will cover method study first and then work measurement, the how to and then the how long. Probably the two most common tools used by an apparel engineering are stopwatch and a calculator. There are a number of fairly common techniques used by apparel engineering that we would like to cover briefly. Some of these are important enough to deserve separate modules. For now, it is ideal that you are exposed to the following techniques. These includes the method analysis, time study, capacity study, follow-up studies, incentive plans, drilling trading, statistical quality control and scheduling systems. A method analysis is the procedure of studying methods used to determine the best way of job. An apparel engineer studies not only the way in which the operator handles the work, but also the machines used and the layout of the workstation and the work aids that are used. One of the most important traits of an effective apparel supervisor is the ability to recognize good or bad methods among operators and to correct when necessary. The whole purpose of a method analysis is to find a better way to do the job. Here are some of the common ways of performing a method analysis. Observation. This includes reviewing the method over and over. Hand chart. In this method, a description of simultaneously movement of left and right hand is written down. Principles of motion economy. In this method, the motions is used to compare a checklist of proven economical motions. Slow motion analysis. In this method, either motion pictures or videotapes are used to slow down activities for better observation. This is the 7-step procedure to conduct a method study. In the first step, the work to be studied and selected. The objectives are then defined. Relevant information is recorded and then examined. Now an improved method is developed and installed. Finally, the improved method is maintained. All methods improvements have a cost, but some cost far more than others. The highest productivity is achieved when we reduce the number of motions, reduce the distance to move, reduce precision, reduce eye shifts and simplify graphs. The highest productivity is also achieved when we toss, dispose rather than place dispose. Make the best use of both hands. Encourage rhythms and promote natural postures as well as movement. These questions are fundamental to a sewing operation. Is this operation necessary? Should this operation or portion of the operation be combined with another operation? Is the operation performed in the correct sequence? What sewing machine attachment or work aids are needed? Will the operation yield satisfactory level of quality? Other questions that are fundamental to a sewing operation are: will the operation yield satisfactory level of quality? What type of the training curve will the job yield? What material uses factors are affected by the job? What principles related to the uses of human body should be taken into account? What considerations on space and indirect labor requirement such as helpers apply? This list can be used to check items used during a sewing operation. Leave parts is best position. Parts located as close to the needle as possible. Grasp the parts from the original bundle. Parts got without looking. Parts got during the sewing period. This checklist can be used when preparing a needle. Assemble parts or fold directly in front of needle. No reposition. Insert part in folder with a single push. This checklist can be used during sewing. Retain original alignment of parts while sewing. Resume sewing after start without pause. Quick turns when sewing. Continuous or full speed sewing. Needle stops in correct position. This checklist can be used during disposal. Dispose by throwing and dispose without looking. This list can be checked to study the motions used during a particular operation. The simplest motion pattern is used. The principles of motion economy are being enforced. Once the engineer performs the method analysis, he will then probably make a time study to document the standard time required to perform the job using the method decided upon. The actual timing that is done is simply a matter of clocking the time the operator requires to perform the job. The apparel engineer must then do two other things before his time study is completed. First, he must grade the operator. This means he must decide if the operator is working at a pace that is normal, above normal or below normal. The objective of time study is to find the normal time. After he has graded the operator, the engineer must then apply allowances to the standard time he has developed. These allowances would cover breaks, machine delay and personal time. Once this is done, a standard can be developed to produce the number of units expected to in a normal working day. A capacity study is similar to a time study in that operator is timed, but the purpose is not to develop a time standard, but rather find out the operator's potential performance level. When we make a capacity study on an operator, we are measuring the performance he or she should attain. If he or she continues to work at the same pace and use the same method as observed during the study. This means that at the end of the study, we can say that operator has the capacity to be 120% performer or whatever performance level the study indicates. Here are some ways by which supervisors find it useful to measure the production capabilities of their operators. Check quota, motivate operators and measure section production capacity. It is really fair common occurrence for a operator to complain to her supervisor, I cannot make the quota on this job. It is too high. When a new quota is set, the supervisor may have a group of operators making this complaint. There is quite a difference between what an operator says and what he or she can do and what he or she can actually do. This is especially true when new quotas are involved. A capacity check can measure what performance the operator is capable of achieving, and this can be compared to the quota to test its fairness. The supervisor can then answer the operator's complaint based on facts. One of the main duties of a supervisor is to motivate her or his operators to perform at the highest level possible. In many cases, however, operators perform at less than their capabilities simply because they do not realize what their full capabilities or capacity are, or do not realize what it would mean to them to perform at this level. It is not at all unusual in making capacity study to discover habitual 90 or 95% operator making capacity of 110 or 115. The word habitual may be part of the answer. Some operators get into habit of being 90% performers. Once it becomes a habit, the operator tends to think that 90% is all she can do. Generally speaking, people can do what they think they can do, but usually what they think they can do is less what is actually achievable. The capacity study is a 10-cycle study to estimate an operator's production ability. If the actual production and capacity are different, then follow-up studies should be made. During the capacity study, the operator's average time per cycle to showing her operation is determined. We then assume the operator works at this pace all day and takes the full amount of lost time, that is machine delay, personal and fatigue time, provided for in a target. The time left after lost time has been deducted is called the available swing minutes. Operators benefit from capacity study only if we spot wastage motions and make suggestions and corrections. The result of every capacity study should be reviewed with the operator. By measuring individual operator capacities, supervisors can determine the overall capacity of their section. The section is simply the sum of individuals. This is useful to a supervisor in setting production and performance goals for her section or his section. It can give the supervisor and her or his operators common goals to work towards. These things are going to occur regardless of operator's ability. Therefore, they are not considered to be a measure of how he or she is able to perform his or her job. When this type of delay does occur, it will cause the operator to take longer on that particular cycle than he or she normally does. In making a capacity study, we would circle such a cycle when it occurs and not use it to calculate our average cycle. A follow-up study is a means of measuring exactly what is happening performance-wise or an individual operator or a group of operator. In making the follow-up study, the engineer records operator performance and also measure any delay that hampers performance. The development of a fair incentive plan for operators is a basically function of an apparel engineer. Many companies place their operator training programs under the engineering function, especially when some form of drill training is used. Drill training is a system in which jobs to be taught are analyzed and broken down into job parts. The operator learns the job one part at a time, and this enables his or her to perform faster. If he or she tries to learn the whole job at once. Statistical quality control is a means of sample inspection that is designed to measure and control quality without having to inspect each and every unit produced. Engineers are becoming increasingly involved with the development of systematic approach to production scheduling and work process control. At this point, we should have a better understanding of engineering than you did. Some of things covered are just as valuable to you as executive as they are to engineers. Our purpose is not to make you into engineers, but to provide you with some additional tools that will help you effectively supervise. This module reviews important definitions and terms associated with apparel manufacturing. There are steps that are used for the time study procedures. Observe the job, analyze to determine the elements, Define the breakpoints, record the elements. Rate each element and compare it with the accepted standard. Try to rate each cycle. Use a stopwatch to time each element. Select the elements to enable you to do this. This gives the raw element time. Calculate the average of the selected element time. This gives the average element time. Multiply the average element time by the rating. This gives the basic time for the element. Add the basic times for all the elements. Make sure the frequency of the different elements are counted for. In particular, bundle handling will apply once per bundle. This gives the basic time for the operation. Add allowances, personal fatigue and machine delay. This gives the standard time for the operation. Elements are small components into which an operation is divided for time study purposes. They are selected for convenience of observation, measurement and analysis. A breakpoint marks the end of one element and the beginning of the next. The total of all elements in an operation represents the operation cycle. The cycle time is the time from one point to one garment to the same point to the next garment. Operations are divided into elements for following reasons. It permits comparison of same piece of work in different cycle of operation. It allows operators to work at different speeds at different part of the work cycle. Operations are divided into elements for these reasons. It enables these to be graded accordingly. This point is particularly significant when there are some of the elements wholly machine controlled, while in others the operator is the controlling factor. It can be used to identify standard elements occurring on more than one job. This can then be used to build up time for another job. Elements should be clearly or fully described on time study sheet, except where they are widely recognized. The breakpoint should be defined if there is any risk of dot, should be selected so that they can be easily recognized. Look for distinctive motion and listen for distinctive sounds. It should be selected with a clear distinction between the machine and manual work. It should not be too short to make timing difficult, not too long to permit an operator's rating to vary. Here are some tips while doing a time study. Be cordial and polite, but don't talk unnecessarily to the operator. Don't stand in front of the operator. Stand in a less discomforting position such as off to the side or in the back. Never sit down during a time study. Always calculate the time study results immediately after gathering the data. Controversy over rating arises from a misunderstanding of what is being rated. An operator's output can vary only if she varies her or his pace of work, varies his or her method. The method includes the motion pattern, number of motions and intermotional delays. When studying, the observer notes the speed at which the operator performs and compares this mentally with the concept of standard pace at which an operator would work. If motivated to apply himself or herself and is free for fatigue, this is a 100% operator. The engineer should have a mental concept of 100% operator, recognize deviation from the 100% and be able to put a relative value onto it. Do not confuse smooth, fluid motion with slow motion. Don't mistake rhythmic intensity for fast, productive motion. Machine-paced operations or elements should be graded 105 to 115 depending on the effectiveness of the operator in utilizing the machine cycle to be their job properly. Before starting a study, the engineer must ensure that he understands the correct motion for the operation and then checks that the operator is using them. The study should not be taken if the motion pattern is incorrect. unless the engineer is prepared to compensate for the incorrect motion in his elemental rating, or else assures himself or herself that the discrepancies is insignificant. Have the quality supervisor or inline sampler checks the bundle. This ensures that the time standard is not established on an unsatisfactory quality standard. Balancing is an important subject that relates to every decision taken on production floor. What is a balanced production system? It is a system where you meet the production expectation and find the same amount of work in process in every operation at any point in the day. To be able to achieve this extremely difficult, but if you choose to have balanced inventory at the end of every day, that will prove to be a reasonable difficult challenge. How do you keep all operations producing at the same rate? Well, this is very difficult since operators' skill vary. We can balance using utility operators that fill holes in production. We can also try to keep operators at the expected level of production or higher if possible. How do we start balancing the production line? Well, we can start by determining how many operators for each operation are needed for a determined level of production. After this, we need to determine how much work in progress we need to anticipate production problem. We recommend a 1 hour inventory level for each operation. A good range would be from 30 minutes to 120 minutes inventory level. Any variation outside this range should be avoided. A variation of this magnitude signifies an unbalanced line and should be looked into immediately. The production line is balanced for a number of reasons. Some of these reasons are: keeping inventory cost low results in higher net income. Keeping normal inventory levels allows the operator to work all day long, giving him or her the opportunity to earn more money by increasing his or her efficiency. Keeping the line balanced lets the supervisors improve other areas because they can use their time better. A production line is also balanced because balanced production keeps prices low, which turns into repeat sales. Balanced production keeps better production planning. It is very important that all supervisors put balancing the line in their daily plan every day. There are 3 rules for balancing. Have at least half an hour of work in progress for each operation. Solve problems before they become very larger. Meet production goals by keeping every operator working at their maximum capacity. There are a number of tools that can be used for balancing. These are applied according to the plant's needs. The most basic one are production sheets, the daily production report, the inventory label by operation, and the production boards. Items to take into account when making balancing decisions are: you should meet production goals by using regular operators, utility operators and temporary transfers. Workflow must be constant through all operations. Avoid overtime, determine human resource needs, balance the human resources, know how much work is needed for each operation, check absences daily, assign utility operators based on absences. Update daily production report every 2 hours. Make balancing decisions every 2 hours and check them with the production manager. Determine how many operators are required to work at 100% capacity. Determine the capacity of actual operators, the actual operators equivalent to the need, the number of new operators that needed to be trained, the number of utility operators, and the need for cross-training staff. This table explains what needs to be done for a particular situation. When the operation can produce more than goal, but right now you have accumulated inventory in front of the operation, keep the operators where they are, but remove some of them when the inventory level is back to normal. If there is only one operator, have him reduce the inventory to a normal level and meet his and her quota. Then put him to work on another operation. When the operation can regularly produce more than the goal and the inventory is at a normal level now, remove resources and place them in other operations. This table explains what needs to be done at particular situation. When the operation can regularly produce more than the goal and the inventory is currently below its normal level, move some resources from current operation to a previous one. When the operation has to required capacity but inventory is high at this point, make sure that the operators are working at full capacity and transfer some resources at this operation temporarily. This table explains what needs to be done for a particular situation. When operation regularly meets the quotas set by production and the inventory is at normal level, do nothing. This is just ideal situation. Keep the operators working at full capacity and inventory at normal level. When the operation are required production, but at this point inventory is at low than normal levels, something is causing the limited supply to this operation. You should transfer resources to the previous operation, but examine it to find what is causing the imbalance. This table explains what needs to be done for a particular situation. When the operation has low production and the inventory is high, it is a bad but not unusual situation. Transfer resources to this operation and make sure operators are at full capacity doing a bundle by bundle follow-up. When the operation has low production but the inventory is at normal level, transfer resources to this operation. Make sure that operators are at full capacity doing a bundle by bundle follow-up. When the operations has low production but the WIP is lower than the normal, something is causing the limited supply of this operation. Investigate the previous operation but transfer resources to this one so that the next operation is not affected. This is balancing matrix. The DPR is a tool that lets the supervisor have an accurate perspective of the situation throughout the day. It helps in making well-informed balancing decisions based on production goals. It enables the supervisor to see if the section is ahead or behind set goals throughout the day. The DPR is a production summary that includes the following informations: general data, that is date, section, operations in section, operator names, production data, production goals and efficiencies. An operation is one of the processes that must be completed in converting materials into finished garment. An operation breakdown is a sequential list of all the operations involved in assembling a garment, component or style. It is used to cost the garments and to establish the workflow for each style. The dependent operation is an operation that cannot be performed without completion of the preceding operation. An independent operation is reverse of a dependent operation. A flow diagram can be man type, material type, equipment and machine types. It is a graphical or symbolic representation of process. Each step in the process is represented by a different symbol or process. This module focuses on ergonomics, the scientific discipline concerned with the understanding of interactions among humans and other elements of a system, and a theoretical approach to the principles, data and methods to design in order to optimize human comfort and overall system performance. Ergonomics, in other words, it is the science of making things comfortable. It is derived from two Greek words, ergons meaning work and nomos meaning natural laws, to create a word that means the science of work and a person's relationship to that work. There are three types of ergonomics: physical ergonomics, cognitive ergonomics, organizational ergonomics. Physical ergonomics is concerned with human anatomical, anthropometric, physiological and biomechanical characteristics as they relate to physical activity. The relevant topics include working postures, materials handling, repeated movement, work-related musculoskeletal disorders, workplace layout, safety and health. Cognitive ergonomics is concerned with mental processes such as perception, memory, reasoning and motor response as they affect interactions among humans and other elements of a system. The relevant topics includes mental workload, decision making, skill performance, human computer interaction, human reliability, work stress and training as these may relate to human system design. Organizational ergonomics is concerned with the optimization of socio-technical system, including their organization structures, policies and processes. The relevant topics includes communication, crew resource management, work design, design of working times, teamwork, participatory design, community ergonomics, cooperative work, new work paradigms, organizational culture, virtual organizations, telework and quality management. The purpose of ergonomics in the workplace is to create a better match between the human body, the work they perform and the equipment they use so as to ensure that a product or service is used comfortably, effectively and safely. The primary goal of ergonomics is to fit jobs to people, not people to jobs. The field of physical ergonomics can be summarized in a series of principles that can be applied at work, at home or at any place. The principles are stated as follow. Work in neutral posture, reduce excessive force, keep everything in easy reach, work at proper height, reduce excessive motion, minimize fatigue and static load, minimize pressure points, provide clearance, move, exercise and stretch, maintain a comfortable environment. The posture provides a good starting point for evaluating the tasks that we do. The best position in which to work are those that keep the body in neutral or maintain the S-curve of the spine. Keep the neck aligned as neck bones are part of the spinal column and thus is subject to the same requirement of maintaining the S-curve. Keep the elbows at sides as the neutral position for the arms is to keep the elbows at the sides and the shoulders relaxed. Keep the wrist neutral by keeping the hand in the same plane as the forearm. Excessive force on the joints can create a potential for fatigue and injury. Therefore, in practical terms, we should think of ways to make improvements and minimize the specific instances of excessive force. It helps to evaluate a task from a specific perspective, keeping in mind the concept of reach envelope, which states that things that we use frequently should ideally be within the reach envelope of our full arm, and the things that we use frequently should be within the reach envelope of our forearms. Working at proper height always makes things easier, and therefore a good thumb rule to this is to ensure that work is done at about elbow height, whether while sitting or standing. This principle aims at minimizing the number of motions that we make throughout a day, whether with our fingers, wrists, arms or our back. One of the simplest way to reduce manual repetition is to use power tools. Whenever possible, or another approach may be is to change layout of equipment to eliminate motions whenever possible. Holding the same position for a period of time is known as static load. It creates fatigue and discomfort and can interfere with work. This can be avoided by changing the orientation of the work area, or sometimes extenders to the tools can be added to minimize discomfort. Excessive pressure points are sometimes called contact stress. This problem can be minimized by adding a cushioned grip and contouring the handle to fit our hands while using a hand tool. Again, rounding out the edge and paddling the table at the pressure point in the forearm usually helps. Work areas need to be set up so that there is sufficient room for visibility and movement, being able to see in another version of this principle. Equipment should be built and tasks should be set up so that nothing blocks your view. To be healthy, and the human body needs to be exercised and stressed depending upon the jobs they are doing. For example, one is having a physical demanding job. It may be helpful to stretch and warm up before the strenuous activity. However, if someone is having a sedentary job, they can take a quick energy break. This principle is more or less a catch-all that can mean different things depending upon the nature of the types of the operations that we do. However, there are certain issues that affect the environment. One common problem is lighting. In the computerized office, lighting has become a big issue because the highly polished computer screen reflects every stray bit of light around. One good way to solve lighting problem is by using task lighting, that is, having a small light right at your workplace that can be oriented and adjusted to fit your needs. Vibration is another common problem that can benefit from evolution. As an example, vibrating tools can be dampened. The final module highlights the importance of facility layout and design as an important component of a business overall operation, both in terms of maximizing the effectiveness of the production process and meeting the needs of the employees. The basic objective of layout is to ensure a smooth flow of work, material and information through a system. The basic meaning of facility is to space in which business activities take place. The layout and design of that space greatly impacts how the work is done, the flow of work, materials and information through the system. The key of a good facility layout and design is the integration of needs of people, personnel and customers, materials, that is raw finishes and in process, and machinery in such a way that they create a single well functioning system. Small business owners need to consider many operational factors when building or renovating a facility for maximum layout effectiveness. These criteria include the following: ease of future expansion or change, flow of movement, material handling, output needs, space utilization, shipping and receiving, ease of communication and support, impact on employee morale and job satisfaction, promotional values and safety. Facility layout must be considered very carefully because we do not want to constantly redesign the facility. Summarized Weiss and Gerson. Some of the goals in designing the facility are to ensure a minimum amount of materials handling, to avoid bottlenecks, to minimize machine interference, to ensure high employee morale and safety, to ensure flexibility. Essentially, there are two distinct types of layout: product layout and process layout. Product layout is synonymous with assembly line and is oriented towards the product that are being made. Process layout is oriented around the processes that are used to make the product. Generally, product layout is applicable for high volume repetitive operations, while process layout is applicable for low volume custom made goods. Offices and manufacturing facilities are typical design in different ways, a reflection of the disparate products that the two entities make. A factory produces things, wrote Stephen Cohns in facility design. These things are moved with conveyors and lift trucks. Factory utilities including gas, water, compressed air, water disposal and large amount of power, as well as telephones and computer networks. A layout criteria is minimization of transportation cost. However, Cohns pointed out that the mandate of business offices is to produce information, whether disseminated in physical, that is reports, memos or other documents, electronic, that is computer files, or oral, that is telephone face-to-face encounters form. Cons wrote that office layout criteria, although hard to quantify, are minimize communication cost and maximize employee productivity. Layout requirements can also differ dramatically by industry. The needs of service-oriented businesses, for instance, are often predicted on whether customers receive their service at physical location of the business, such as at a bank or a pet grooming shop, whether the business goes to the customer's home or place of business to provide the service. That is as with exterminators, home repair businesses, plumbing services, etc. In the latter instances, these businesses will probably have facility layout that emphasizes store space for equipment, chemicals and paperwork rather than spacious customer waiting area. Manufacturers may also have significantly different facility layouts depending on the unique needs that they have. After all, production challenges associated with producing jars of varnish or mountaineering equipments are apt to considerably different than those of making truck chassis or foam beach buoys. Retail outlets comprise yet another business sector that has unique facility layout needs. Such establishments typically emphasize sales floor space, inventory logistics, foot traffic issues, and overall store attractiveness when studying facility layout issues. Kohn also observed that differences in factory and office layout can often be traced to user expectations. Historically, office workers have been much more concerned with status and aesthetics than factory workers, he noted. A key consideration in many office layouts is who will get the best window location. To show this status, executives accept in addition to preferred location to have larger amount of space. Generally, a person holding a higher rank expects more privacy or more plus physical surroundings. In addition, Kohn also stated offices are designed to be tasteful and to reflect the organization's approach to business dealings. Conversely, in factory setting, aesthetic elements take a backseat to utility. Given this emphasis, it is not surprising that a general rule office workers will enjoy advantages over their material production co-workers in such areas as ventilation, lighting, acoustics and climate control. Facilities should be designed so that they can be easily expanded or adjusted to meet changing production needs. Although redesigning a facility is a major expensive undertaking not to be done lightly, there is always the possibility that redesign will be necessary, said Wes and Gerson in his book Production and Operation Management. Therefore, any design should be flexible. Flexible manufacturing systems most often are highly automated facilities having intermediate volume production of a variety of products. Their goal is to minimize changeover or setup times for producing the different products while still achieving close to assembly line, that is single product or production rates. The facility design should reflect recognition of the importance of smooth process flow. In the case of factory facility, the editors of How to Run a Small Business state that ideally the plan will show the raw material entering the plant at one end and the finished product emerging at the another. The flow needs not be a straight line. Parallel flows use a pattern or even a zigzag that ends up with the finished product back is the shipping and receiving bays can be functional. However, backtracking is to be avoided in whatever pattern is chosen. When parts and materials move against and across the overall flow, personnel and paperwork becomes confused. Parts are lost and attainment of coordination becomes complicated. Small business owners should make certain that facility layout makes it possible to handle materials such as products, equipment and containers in an orderly, preferably simple manner. The facility should be laid out in a way that the conducive to helping the business meets its production needs. This aspect of facility design includes everything from making sure that traffic lanes are wide enough to make certain that inventory storage warehouses or rooms utilize as much vertical space as possible. The J.K. Lazar Institute counseled small business owners to leave ample room for this aspect of operation. While space does not tend to fill itself up, receiving and shipping rarely get enough space for the work to be done effectively. It said in How to Run a Small Business. Facilities should be laid out so that communication within various areas of the business and the interaction with vendors and customers can be done in an easy and effective manner. Similarly, support areas should be stationed in area that help them to serve operating area. Since countless studies have indicated that employee morale has a major impact on productivity, Weiss and Jerson counsel owners and managers to heed this fact when pondering facility design alternatives. Some ways layout design can increase morale are obvious, such as providing for light colored walls, windows in a space. Other ways are less obvious and not directly related to the production process. Some examples are including a cafeteria or even a gymnasium. In facility design, again, though, they are cost to be traded off. That is, does the increase in morale due to a cafeteria increase productivity to the extent that the increased productivity covers the cost of building and staffing the cafeteria? If the business commonly receives visitors in the form of customers, vendors and investors, the small business owner may want to make sure that facility layout is an attractive one that further burnishes the company's reputation. Design factors that can influence the degree of attractiveness of a facility include not only the design of the product area itself, but the impact that it has on, for instance, the ease of fulfilling maintenance or cleaning tasks. The facility layout should enable the business to effectively operate in accordance with occupational safety and health administration guidelines and other legal restrictions. You are reached the end of this unit. To summarize, in this unit, you have reviewed various industrial engineering concepts. You have also learned about time study, line balancing, operation breakdown, independent and dependent processes, as well as importance of ergonomics at the workplace and techniques to design a suitable workplace layout. Thank you very much.